Hello once again, this is Mr. Wakefield here. I'm looking at the last section of Chapter 2, 2.5. And in a sense, we're actually going backwards from what we did in Section 2.4. In 2.4, what did we do? We gave an equation. We looked at an equation, and then we had to graph it, right? Okay, we took that, and we had two different methods. Not including the ones where a variable was missing. That had methods as well. But we had a method to use in order to go from the equation and the problem to actually being able to graph it. Well, in this section, it's the opposite. What we do in this section is we're going to start out by describing the graph. You won't see the graph, but it'll be described, okay? Like this one has a slope of -4, and it passes through this point, okay? That's what the line is going to do. So they describe the line. And then what you got to do is you got to actually come up with the equation that it came from. And so it's the opposite, because now the end of the problem, your answer is going to be the equation instead of in the last section where the equation was basically the question. It's what you started with. So let's go ahead and jump into it. There's a number of different ways to approach this. We'll go through each one of those carefully here. First of all, it says write an equation of the line that satisfies the given conditions, okay, and then it describes the graph. Put the answer in slope-intercept form, which, as you know, is y equal to mx plus b. We learned that in the last section. But then they want you to put it in function notation. So what that means is they want you to take the y equal to mx plus b. At the very end of the problem, after you get it into this form right here, they want you to take that and then just simply change the y to f of x, because we know that f of x and y are the same thing, okay? And so they want you to put it in function notation, which just simply means to put the f of x in there instead of the y, okay? So we'll put it in this form first, and then we'll just change the y to f of x, and that'll be it. Okay, now, as you can see up here, we have a number of different formulas that we can use in order to come up with the equation. As you know, unless it's a horizontal or vertical line, as we learned in the last section, and we'll learn about how to recognize that coming up here when it's horizontal or vertical. But other than that, you guys, x and y right here, I'll put them in red here. Let me zoom in so you can see that. X and y, I know it doesn't look like it's red, but I highlighted it there. Those are your variables in the problem. They are supposed to be in your answer. Okay, don't try to change those. All right. Now, again, if it's horizontal or vertical, it'll just be one variable. But otherwise, it should have these two variables in the answer. Okay. There shouldn't be any other letters in your answer, and so that means that the M right here, the M and the B. Okay, we actually got to figure out what those are equal to, and we got to actually have numbers in the place of the M and the B right there. So we'll do that, all right? And it says here that when you use this form right here, when you know the slope and the y-intercept. Because if you know the slope and the y-intercept, then you just put the slope right here, and you put the y-intercept right here, and then you're good to go. That's it, all right? So let's try that in this first problem here. You can see here that we know what the slope is. So there's your M right there. Didn't even need to figure that out. They told you that. Okay. Now this right here, let's talk about this. You may have noticed, and if not, I'll talk about it right here. In the last section, though, notice that... there it is right there. Actually, let me show you where all of the answers are located here so we can see more examples all at once. Here we go. You'll notice here that whenever the graph crossed the y-axis, okay, the x was always 0. So like this point right here where it crosses the y-axis, which is otherwise known as the y-intercept, okay, that is where you have x equal to 0 combined with -6. Same thing over here, okay? You can see that 0, -6 is where it crosses there. And then even over here, where it crosses the y-axis, that point is 0, 5. What do all three of those problems have in common? They have in common the fact that where it crosses the y-axis, in other words, the y-intercept, x is always equal to 0, always. And so that's important here because as we go back to the first problem here, since let's write this down. Since x is equal to 0, that must mean what? That must mean that b, remember b is the y-intercept. We learned that in the last section. B is -3. So in other words, B, you guys, is always the y-coordinate that pairs up with 0. B is always the y-coordinate that pairs up with 0, but this has to be 0. If this is not 0 right here, then you can't do that. So like on the next problem, see how it's 15 in the x spot right there? You can't say that B is -4. That's different. But if the x is 0 right here, then you're allowed to say that the number paired up with it is your B. So now we know what the m and the b are. So all you got to do, remember y and x are going to be a part of the answer here. And so y and x will be in their normal spot right here. And then we just got to put the m right here. So you have y equal to mx plus b. Okay, so I have my y and x just like right here. I put the m being multiplied by the x, -4 times x, and then I put the plus b right here. So that would be plus -3. Now, as you know, though, when you add a negative, that's the same thing as subtracting 3, and so you could say it that way as well. You could also say plus -3, but this looks better. Okay, but yeah, anytime you add a negative term, okay, to something, you can change it to minus like that. Last thing we need to do, as I said, after you get it into this form right here, you need to change the y to f of x, and then our final answer is this right here. And there you go. So that's what you do when you have the slope and the y-intercept. If you know it already, you can just use that formula at the very top of the page and you're good to go. How is this next problem different, though? Again, it gives us the slope, so that's the same thing, okay? Just like this problem gave us the slope, this one does too. And so you could say that m is equal to -2/5. Okay, that's great. But here's the problem, though. Since x is not 0, and when I put a slash through the equal sign right there, you guys, that means not equal to, as you can imagine. Since x is not equal to 0, I can't say what? I cannot say that b is equal to -4. I'd like to, but I just can't do it. Okay, so I know what the m is, but I don't know what the b is. I'm not allowed to say that it's -4. Okay, so let's go up here. I know what the m is, but I don't know what the b is. When that kind of thing happens where they give you the slope, -2/5, and they give you at least one point that it passes through, one point on the line, in other words, one point that it passes through like this right here, but it's not where x is equal to 0, okay, it's not, then what you do is you use what we call the point slope form, okay, and you would put the slope here, like always, where the m is. And then you would put the that one point that they gave you, the one that's not the y-intercept. Okay, you would put that here and here. Notice it has those little ones underneath it. They're trying to tell you that those are not meant to be the same thing as y and x. Y and x are the variables. The y1 and the x1 are the actual constant numbers that come from the point that it passes through that they gave you. Okay, and that would be 15, -4. So keep your variables here and here where it's red, but put the actual point that you know that it passes through, put that in the y1 and the x1 spots. Okay, so let's try that right now. So we're going to put -2/5 on the right-hand side of the equal sign there where the m goes. All right, and then you're going to put, I'll go and just write it right here so we can just refer to it. There we go. And then I'm going to put the x right inside the bracket, just like up here. I'm going to put the y at the very beginning of the problem, just like that right there. And then it tells me that the 15, -4 needs to go into this spot right here, x1, and this spot right here, y1. So if they give you 15, -4, you're supposed to put the 15 here, and then the -4 right here. But let's talk about that. Remember, there's already a minus sign, you guys, built into the problem. And so if you plug in 15 behind that, that's x minus 15. Everything's fine there. But here's the thing. If you have negative 4 that you're supposed to plug into here, which is what this says you're supposed to do, negative 4 is supposed to be the y1. That is minus a negative. That's a double negative, you guys. And when you're subtracting and you have minus negative, the minus negative becomes plus. And so that's going to be plus 4. So let me go over that one more time. If you have a minus, all right, and then you plug in a positive number behind it, it'll stay as minus. It's just minus 15. But if you have a minus and then you plug in a negative number behind it, that becomes a double negative on the subtraction, and then that'll become plus. Okay, so here is your equation. We're not done yet because we still got to put it into this form right here. But at least initially, this is your equation. So here's what you got to do in order to get it to look like this. Just a few more steps. What you got to do, remember, you got to first of all get y by itself, and then you can do the f of x thing. How do I get y by itself? 2 steps. You first of all distribute this out. Okay. Let's talk about what that is. Negative 2/5 times x is negative 2/5 x. Anytime you multiply a constant number, even if it's a fraction, as long as it doesn't have a variable in it, and negative 2/5 doesn't have a variable in it, that would make it a constant number. That the fraction is. The fraction is a constant number. So if you're multiplying a constant number times x, just x, not 3x or 5x, but just x, it just sandwiches together negative 2/5 x. It's no different than if you did 3 times x. 3 times x is 3x. 5 times x is 5x. So same thing with the fraction. Negative 2/5 times x is negative 2/5 x. Over here, we got to be a little bit more careful. Let me review multiplying fractions with you here when you got negatives involved. You got negative 2/5 times negative 15, which is the same thing as negative 15 over 1. When you multiply a regular number that's not a fraction, you guys, times a fraction, you got to make this into a fraction too, so that you can multiply the fractions together. And then, how do we multiply fractions together? We multiply the tops and the bottoms, but you got to be careful when you have a negative sign outside of at least one of the fractions. Remember, this is a negative fraction times another negative fraction. All right, so the answer is actually going to be positive. So we'll have to adjust that, okay, here at the end. So, but 2 times negative 15 is negative 30. 5 times 1 is 5. But because it's negative times negative, it's supposed to actually be what? It's supposed to actually be positive 6. Okay, because 30 divided by 5 is 6. Actually, negative 30 divided by 5 is negative 6. All right, that's actually what we have. It's negative 6 right there. But like I said, because of this negative on the outside, that makes the overall answer actually positive right here, because negative times negative is positive. So you just need to change the sign of the answer after you do the normal thing here, and you multiply the top numbers and the bottom numbers together. Okay, so always be careful when you're multiplying fractions. If you have any negatives that are outside of the fraction especially, you got to make sure the sign of your answer is correct. So negative times negative is positive. It's going to be positive 6, so I'm going to say plus 6. Remember, when you distribute, you got to put pluses and minuses in front of each one of your answers. And so don't just say 6, say plus 6. And then finally, we need to move the 4 over in order to get the y by itself. So if you've got y right here, and then you've either got plus 4, or like if you have like minus 5 or something like that, whether it's plus or minus, you just move it over by either adding or subtracting. In this case, I subtract the 4 because the 4 was positive right above it there, and that makes it cancel. So my final answer then, if I move it over and I combine like terms, I get negative 2/5 x plus 2. And there you go. Now that I've got it in the correct form here, y equal to mx plus b, I now need to what? I need to put the f of x thing right there, like that. And then you're done. Okay? So, if you know the slope and the y-intercept, And you will know the y-intercept if it says 0 comma something. Then you just use the y equal to mx plus b formula directly. You just directly plug the m and the b into that, and it's a much shorter problem. On the other hand, if you know the slope and they give you a point that it passes through here where x is not 0, then you do what we did here. Okay? So those are the two different scenarios we looked at so far. Another scenario that you could run into, which is different than those two, is the following here as we go on into the second page here. See how it says in problem C, they don't give you the slope this time. This is the first time that they haven't given us the slope. All right. Instead, what they do is they just give you 2 points that it passes through. Okay, there's good news with that, though. Anytime that you know 2 different points on a line, you can figure out the slope automatically. There's a formula on the front side of the worksheet, about halfway down the page. It says that if you know 2 points on the line, and we'll just say that these are the 2 points. In fact, you know what I'll do? I will go ahead and take these 2 points in the current problem right here, and I will put them right above this so that you can see how it works directly here. Okay, so these are the 2 points that we're using in the current problem. And what this formula right here is telling us to do in order to figure out m is to take the second y value minus the first y value. y2 minus y1. Second y minus first y. Okay, but how we plug that in, we need to be careful. All right, -3 minus -8. Remember what we said in the last problem. If you plug in a negative number behind a minus, that's a double negative there on the subtraction. And so that's actually going to make this, instead of saying -3 minus -8, which is correct, but there's an easier way to write it, and that is to say -3 plus 8, because it's minus negative, and we know that minus negative means plus. Let's write that down up here. Actually, I'll write it down here. Okay, so we got m is equal to -3. Again, change that to plus 8 because it's a double negative. This one on the bottom, though, it says second x minus first x. All right, that means to do the second x here, 8, minus the first one, 4. Notice that's not a double negative. It's just minus positive 4. It's not minus -4. That would be different. But if it's just minus positive 4, then that's just going to stay as minus. It's not a double negative, so it doesn't change to plus. Okay? So that's why this up here is plus and this down here is minus. Even though these both say minus right here, because you had the double negative where you had minus a negative here behind the, in other words, you had the minus. You guys, I'm not talking about what's in front of the minus there. I'm talking about when you have a minus and then a negative that you plugged in behind it, not in front of it, but behind it. Okay, that's when it's going to change to plus because you're subtracting a negative. Okay. What's in front of the minus, the y2, that doesn't matter if that's positive or negative, okay? As far as when it comes, whether or not it's going to change to plus, that all has to do with whether or not you plug in a negative behind the minus, not in front. So minus -8 becomes plus 8. So we got what here? We got 5/4 when we figure out what the top and bottom are equal to. As we always do when we have a fraction with no variables in it, order of operations tells us to figure out the top and the bottom and then put this in lowest terms if it's not already. It's already in lowest terms, so I'll leave that the way it is. And we have our slope. Okay, now that we have our slope, you guys, what we do is we take the same approach, basically the same approach that we just took in the first two problems. Let's take a look at that again. When we knew what the slope was, you guys, we had one of two decisions to make. If we had a point, in other words, that had 0 right here in the first spot, then you then take the number that pairs up with it, and that becomes your b, and you use this formula right here, nice and easy. But if you do not have a point where x is equal to 0 right here, then you did this secondary formula, which we call the point slope formula at the top of the page. Okay. Well, look at this here. 4 and 8 are your two x numbers, aren't they? Neither one of them is 0, unfortunately. And so therefore, I need to take this approach over here because neither one of them have the x equal to 0 here. All right, so we can't do what we did over here, but we can do what we do here. The only question at this point, though, is before I actually go ahead and do this method, is we have 2 points this time. So how do I know which point to use? Well, notice the directions up here when it says to use this formula. It says that the point that you use could be what? Any point on the line. Any point at all. And so that means that it's your choice. Okay, you can use either one of these 2 points here, since they said that you can use any point you want as long as it's on the line. And when they say it passes through, that means that it passes through the line. That means it's on the line. Okay, so let's go ahead and decide now which one we want to use. I will go ahead and use the second one. You're welcome to use the first one. Our answers will look a little bit different at first if you use a different one than I did, but it'll come out the same in the end, guaranteed. Okay, but I'll use the second one here. I'm not saying the second one is better than the first one. It really doesn't matter, but you could do either one. I just happened to pick that one. So we put the 5/4 in the normal spot right there when we use that point slope formula. We put the y and the x in their normal locations. And then since I'm using this one, the 8 then is going to go in this spot right here. Okay. And yeah, that's right. Just wanted to make sure. So the 8 goes into that spot right there, and the -3 goes over here. But remember, if you're plugging in a positive number behind a minus sign, and remember we're plugging in the 8 behind the minus sign here, it stays as minus. Okay, it's not a double negative. But since you're plugging in -3 behind the minus here, it becomes what? It becomes +3. All right, so that's how we do that. Then we do those same steps that we did on this problem right here in order to get it down to the final answer. What are those steps again? They are to distribute this out and then move over the 3 after that. So 5/4 times x, just like the -2/5 in the last problem, 5/4 times x is just 5/4 x. 5/4 times -8, let's look at that. Like that. What is that going to be? That's going to be -40 over 4. Just double check your sign like I taught you a moment ago. When you're multiplying fractions that have negative numbers in them, check your signs. This is a positive fraction times a negative fraction. So this should be a negative answer. -40 divided by 4 is equal to -10, and that is negative, so I don't need to change the sign. I just wanted to make sure that the sign came out correct again there. So -10 right there. We then subtract the 3 over. Okay, and that gives me what? That gives me y is equal to 5/4 x, and then -10 minus 3 is -13. -13. Let me zoom in there for you. Okay, y equal to 5/4 x minus 13. Okay, I apologize there. That I kind of put that on a tight spot right there. It's kind of hard to read that. Let me make it a little bit easier for you. Okay, put that a little bit up higher there. There we go. So again, 5/4 x minus 13. Last thing we do is what again? We change after you get the y by itself and it's equal to mx plus b. In that mx plus b form, you then change the y to a f of x, and then you're done. All right. Now, so when you have 2 points, they don't give you the slope. They just give you 2 points that it passes through. You use this formula, this one right here, to determine what the slope is. Once you determine what the slope is, you then do what we did in the first two problems. If either one of these two x numbers is equal to 0, then the number that pairs up with that x equal to 0 number, just like in the first problem here, whatever that ends up being, that's going to be your b number here, just like right here where b was equal to -3. But as we saw in problem C here, if neither one of the x numbers is 0, then you got to do that point slope formula, this one right here. Okay? Now, what happens? Actually, let me just go ahead and do it first. I can't really say what happens yet until you actually see it. All right, and then I'll explain it so you'll know for the future. Okay, so you can see that this problem looks very similar to the last one. They just gave you a couple of points. So once again, because of that, we are going to do the same thing where we are going to take the second y value minus the first y value, and that goes on top. Remember, the y's always go on top in this formula. So we get -4 minus -4. Look up here as a reference. -4 minus -4. There's that thing again where the negative number is behind the minus sign. So that's going to make this what? That's going to make this -4 plus 4. Okay. Down here, or rather with the x's, they will go down at the bottom of the fraction though. We got what? We got 3 minus -1. 3 minus -1. Again, there's another double negative, so we get 3 plus 1. Okay. A negative number, -1 in particular, was plugged in behind the minus and makes it a double negative, and it makes it plus 1. What is this equal to? 0 over 4. Let's talk about that for a moment. In section 2.3, remember I mentioned, let me bring that up here real quick for you to refer to. I mentioned in section 2.3 that when you have a 0 on the bottom of the fraction, that is an undefined answer. That's an undefined number. Okay. However, in fact, let me go ahead and put that side by side right here. Suppose instead of having the 0, I'm back in 2.3 here just temporarily. You could put this on your current sheet if you want. But 0 divided by 4. If the 0 is on top instead of on the bottom, it's a completely different situation. Let me prove that to you here. Remember we said that when you divide two numbers, it's like taking the bottom number and saying, okay, what do we multiply by in order to get it equal to the top number? Well, 2 times 3 is equal to 6, and that's the reason why this answer right here is 3. Well, over here, let's ask the same question. Bottom number times what is equal to the top number? 4 times what is equal to 0? Well, we know that 4 times 0 is equal to 0. And so even though this one had an undefined answer because there was no answer for it, this one has an answer of 0. So what I'm getting at here is this, you guys. Sometimes you're going to get a slope that's undefined. Sometimes you're going to get a slope that's 0. Okay? When one of those two things happens, let's go back to the front of your worksheet right now. Okay, see where it says right here, if the slope is 0, and if the slope is undefined? Right there. Okay, what does that mean? It tells you how to write the equation, but let me tell you what it means first of all in terms of the graph. If it's 0, that means that the graph is automatically horizontal. Okay? If it is undefined, that means the graph is vertical. Remember we saw in the last section that the way we handle horizontal and vertical lines when we graph them is different than the way we handle the other types of graphs. Okay, this section is no different. When you do the equations, all right, it's also that way where, in fact, let's write that down. We only use these formulas only what? Sorry about that, that came off the screen. Let me get this all on one page. Here we go. We only use these two formulas up here that we've used on the first three problems. We only use these formulas when what? If the graph is neither horizontal nor vertical. Is neither horizontal nor vertical. In other words, if it is horizontal or vertical, which you should be able to discover at the beginning of the problem when you do the slope, like I just did in the current problem. Okay, in other words, let's say you get either a zero slope or an undefined slope. Forget about these formulas in that case, you guys. If you get any other type of slope besides zero or undefined, okay, then use these formulas. Okay, in other words, how do you know when it's zero undefined? If it's zero on top but not the bottom, that's zero. If it's zero on the top, or pardon me, if it's not zero on the top but it's zero on the bottom instead, that's when it's going to be undefined. So when you get one of these two types of slopes right here, forget about those two formulas at the top right here, and instead do what it says right here. And I'll go over that here in just a moment. Okay, but I just wanted to establish that. All right, so zero or undefined on the slope, we're going to do these two strategies here depending on which slope it is. And then if it's any other type of slope, all right, then you use one of these two because that means that it's neither vertical nor horizontal. Remember, vertical and horizontal are special situations that require different types of rules, just like in the last section. Okay, so let's go back to the current problem. Okay, let me pull that back out here. There we go. So since the slope is 0, 0 divided by 4 is 0, okay, that means what? That means that the graph is horizontal, as I just noted on the front of the page there. Okay, what does the directions say for that? It says when the slope is 0, the equation can be written like this right here. Okay, once again, the y is the variable, and all the other letters besides y and x are going to be the constant numbers where you got to actually put a number there. The x and the y are a part of the answer. Don't change the x and the y. But all the other letters, including the x1 and the y1 and the m and the b, all of those, you need to replace those with actual numbers in order for the problem's answer to be complete. Okay. It ends up being, let me zoom back in there. It ends up being y equal to something. Like I said, y equal to what though? They want us to write y equal to something here. Okay, how it works is like this. As I mentioned in the previous section, when you have a horizontal line, all of the y's will be the same. And it's not a coincidence then that these two y's are the same then. All right, because all the y's are the same when you get a horizontal line, always. And so since these are both equal to -4, that means that the y's are always equal to -4. Okay? And when that happens, you guys, guess what? Not a surprise here. The final answer, at least before I put the f of x in there, the final answer is just y equal to -4. So when you do y equal to something, just figure out what that common number is that y is always equal to, and you can see that right here. And then that's what you put on the other side of the equal sign. Okay? So once you get the y by itself, I know this is not mx plus b, but it's still y by itself, so still change it to f of x after that, just like we did in the previous 3 problems, and then you'll be done. Okay? I'm going to do one more problem here. I know I've been talking for a while, but since it ties in so closely to this, it's a quick problem here. I'll do that, and then I'll ask you to do a couple problems yourself here. Look down here at problem E. Once again, it gives us 2 points. So what do we always do when they just give us the 2 points? We do this slope formula with the y2, y1, x2, x1. And we say what? We say 5 minus -3. Same thing as 5 plus 3 because it's got the double negative. And then on the bottom, though, what happens there? 2 minus 2, right? So after we figured out, we got what? We got a undefined fraction. Remember when the 0 is on the bottom, that's undefined. Okay? Undefined. what does an undefined slope mean? Okay, it automatically means, you don't use those two formulas at the top of the worksheet, where it says slope intercept and point slope. You don't use those when it's horizontal or vertical here. Okay, no, we're going to use this strategy here. It says if the slope is undefined, the graph is vertical, and we're going to say what? We're going to say that x is equal to, and we just put the letter A there just to put something there, all right? But the important thing is that since it's not x or y on this side of the equal sign, you just figure out what that number's got to be, and that becomes your answer, x equal to some number here that we need to figure out still. But it works very similar to the way that the last problem worked, okay? I had to figure out what goes on the other side of y right here when it was horizontal, and it was based on what the y's are always equal to. Well, as we learned in the last section, when you have a vertical line, all the x's are now the same. When it's horizontal, all the y's are the same, but when it's vertical, all the x's are the same. So that same common number there, as you can see there, is 2 because both of the x's are 2. So that means what? That means that all of the x's are all x's equal 2 then. And when all the x's equal 2, that means that your final answer is going to be just simply x equal to 2. Just like when all the y's were equal to -4, your answer was y equal to -4 before I changed it to f of x. Okay, so when it's horizontal or vertical, that's what you do. All right, if it's vertical, you look for the common x, you make x equal to that. When it's horizontal, all the y's are supposed to be the same, so you look for the common y value here, and then y is simply equal to that. One last note here, though, on this current problem, do not change this to f of x. Remember, f of x, you guys, is equal to y. It is not equal to x. It is equal to y. There is no f of x in this problem, okay? Remember, we said that vertical lines are not functions, so you shouldn't have an f of x anyway. All other lines are functions, but not vertical lines, though. So don't feel like you got to try to put an f of x in there. Vertical lines should not have one. Okay, and there's no y here anyway. All right, so please try right now. Don't do the other ones yet, but please try just problems 1 and 2 right now. Pardon me, there's one other thing I want to mention here before you try these. The x-intercept and y-intercept, what does that mean? As you probably noticed on section 2.4, and we mentioned this already with y-intercepts, with the y-intercept, the x is always 0. We already talked about that. But notice that for the x-intercept, the y is always 0. Okay, so for y-intercepts, x is always 0. X-intercepts, y is always 0. And so that's important here because then if they say that the x-intercept is 4, that means that x equal to 4 pairs up with y equal to 0. And if the y-intercept is -2, then that means that x equal to 0 pairs up with y equal to -2. Okay, y equal to 0 for x-intercept, x equal to 0 for y-intercept. Now that you've got these 2 points, you just do the same thing that we've been doing on these last few problems where you just got 2 points. You figure out your slope, and then you go from there. All right, so please try right now. Don't do the other ones yet, but please try just problems 1 and 2 right now. Hit the play button. We'll look at those answers, and then we'll go over these last 3 problems after that. Okay, let's take a look at number 1 right here. The slope here, second y minus first y, second x minus first x, I wrote all that over here. We end up getting -8/6, which, sorry, that came off the screen there. That simplifies to be -4/3. And you could put the negative in front as long as it's a negative fraction. Remember, when it's a negative fraction, it could either be in the front only, in the top only, like right here, or on the bottom only, okay? Any one of those things would still be negative, and that would be fine. So I plugged it in here, and I picked the first point here to plug in with it. Okay, you could have done the second one. Don't worry, that'll still come out the same in the end. But I went ahead and picked this one. Since I had a choice, I decided to pick the first one this time. So because of the fact that the x gets plugged in behind the minus right here in the normal formula, that's going to make it a double negative. X minus x1 would be x minus negative 3. Minus negative 3 is going to be the same thing as plus 3. But on the other part here, we have y minus 6. That's not a double negative because that's positive 6. So it's just minus 6. And that's the initial equation here. But we still need to get it into the correct form. So I need to distribute, just like I've been doing. Okay, distribute that out. You can see I did the work over here. I figured out that that was negative 4 over 1. You don't need to do the cross-canceling stuff. We'll review that later. You could just do negative 4 times 3 and 3 times 1 would be negative 12 thirds. Either way, it ends up being equal to negative 4, no matter which way you do it anyway. Okay, I just showed a different way of doing it there, but you can do it either way. Okay, so that's negative 4 on the second part of the distribution. Then you add the 6 over, and you get this right here. Then we change it to f of x, and we're done. Right here. Okay? The second problem. Okay. Same thing. We put the m in there. I'm sorry, we figure out what the m is first. Negative 2 minus 0, 0 minus 4. Again, make sure to do the second minus the first. The second minus the first on both the x and the y. Okay, don't go out of order there. You end up with negative 2 over negative 4. That reduces down to negative 1 over negative 2. You can change that to 1/2 since that's the same thing. It's positive either way. Okay, and so we get 1/2 as our slope. Since this point right here has x equal to 0, we can declare that the negative 2 that pairs up with x equal to 0 is your b automatically. So you don't need to do this longer formula over here in this case because we have x equal to 0 on one of our points that they gave us. Okay, so I went ahead and just plugged in negative 2 into the b, okay, for the mx plus b formula, just like I did in the very first problem that we did. When I plugged in negative 3 for the b, here it's negative 2, and so I plugged that in the same manner. Okay, so we actually end up getting y equal to 1/2 x minus 2, and then I went ahead and changed that to f of x equal to 1/2 x minus 2. And that is basically all the different methods, okay, that you're going to have, all right, for figuring out the equation of a line based on the information they gave you. Okay. One other thing we need to do, though, is that they put one additional concept into this section, and that is, let me get a fresh piece of paper right here again. It mentions the concept of perpendicular lines and also parallel lines. Let's talk about that for a moment. Otherwise, the problems are very similar to the ones that we've already done. It's not a completely different thing, but it is slightly different with the parallel and perpendicular concept. First of all, two lines are parallel if they always are the same distance apart. Okay, they never intersect. But in terms of slope, though, which is what we're talking about in this section, the slopes are the same when you're doing parallel lines. Okay? Perpendicular lines are different, though. Those lines, and just to let you know from a visual standpoint, perpendicular lines are lines that don't just intersect only, but they actually intersect in a special way. They intersect at a 90-degree angle. Like, for example, if you had something like this, and then notice that these two lines right here, this is not just any intersection point right here. This is a 90-degree angle right there. Okay? And so that's what perpendicular lines are. They intersect at a 90-degree angle. But how do we use that here in this section in regards to slopes? Perpendicular lines have slopes that are what? Negative reciprocals of each other. Let's talk about that. It's just like it sounds, though. Remember, a reciprocal means you flip a fraction over. Okay, so let me show you some examples of that right here from some previous notes that I had. Same notes, though. I just got some additional details. Let's say your original slope, you guys, was 3/5, just to make sure you know what a negative reciprocal is. It means to flip it, that's the reciprocal, that would be 5/3, but then they say to take the negative of that reciprocal, and so the 5/3 would then become negative 5/3. So the perpendicular slope then would be negative 5/3 if the original slope was 3/5. What if the original slope was negative to begin with? Then you flip the fraction over and you take the negative of it. If you flip this fraction over, you get negative 6/5. The negative is still there. But when you take the negative of something, all right, what it basically means is you're taking the number and multiplying it by -1. And that always has the effect of changing the sign. Okay, so basically what happens with a negative reciprocal then, as we saw here in each of these first two examples, is that you flip the fraction, but then you change the sign of it. So that's why negative 5/6 becomes positive 6/5. What about if it's not even a fraction at all? Well, remember, you can always take a number that's not a fraction and make it into one. What if this was -6/1? -6/1, that's perfectly legitimate. Okay, then if you flip that over and change the sign of it, you now get positive 1/6. And that's why that's the perpendicular slope there. Finally, if you've got 0, that's the same thing as 0/1, right? Okay, I'm making it into a fraction. If I flip that over and change the sign of it, I get -1/0, don't I? But isn't that an undefined slope when the 0 is on the bottom? So a 0 slope, which is horizontal, would then be perpendicular to an undefined slope, which is vertical. And that makes sense, actually, that a horizontal would be perpendicular to a vertical. If you think about it, you guys, a flat line that goes straight across like a horizontal line would always be perpendicular to a vertical line. Okay, so that makes sense. But let's go ahead and try these problems now. Let's try that out. It says it passes through this point and is perpendicular to the line whose equation is this. Okay. As we did in the previous section, okay, let me pull that back up here. There it is. If they give us an equation and they want us to find out what the slope is, okay, how do we do that? We get the y by itself, we get it into the y equal to mx plus b form, and then we determine what this number is that's being multiplied by the x. That's the slope. Okay? By the way, this is not the actual final answer right here. This is a different equation here. The final equation would be different than this, okay? But we need to use this equation in order to figure out the slope of the line that we're trying to find here eventually. So what I do, just like I did in the last section, in order to get the y by itself, I first of all get the term that has the y in it by itself by subtracting the x over to the other side. And then I divide out by 7. Again, just like I did in the last section. The 7s will cancel right there. Remember, this is -1x. I'm going to go ahead and put the -1 there. You'll see why I'm doing it. Normally, you don't have to do that, but you will this time. You'll see why here in a second, if you don't already. And then positive divided by positive is positive, so I'm going to put the plus there. Okay, and the reason why I got to put that -1 there instead of just negative only is because remember, this is the step from the last section where you have to move the x out of the fraction. So you can't just leave the numerator, the top of the fraction, empty, and you can't just put a negative there. There's got to at least be a number or a variable there. And so since this is actually -1x right here, the -1 now has to become visible so that you actually have something there. Okay? Sorry, I meant to write 7 on the bottom right there. Okay. The x goes outside, not on the bottom, just like in the last section. Do you now see what the slope is? The slope is this right here, isn't it? Just like we learned how to figure it out in the last section. And so that's the slope of this line. But it says that the line that we're actually trying to find right now is perpendicular to that line, the line that is represented by this equation. So this is not the final slope, Okay, perpendicular means we do what here? It means to take that slope right there, flip it over, and change the sign of it. So it becomes positive 7 over 1. Okay, and there you go. All right, and of course that's the same thing as 7. You don't have to say 7 over 1. Better to say 7 when you have a 1 on the bottom. Okay, that way you can not have to write a fraction. Then, now that I know what the slope is, and since it passes through this point, remember on many of the previous problems that we've done in this section, if you know what the slope is, and they give you a point where the x number is not 0, what do we do in that case? We use that second formula, the one where you've got the slope in front of the bracket. You put the x and the y in these two spots right here. And then you put the 5 and the negative 9 into their appropriate spots. And so that's going to be y minus negative 9, same thing as y plus 9, right there. And then since 5 is positive, we're just going to say minus 5. It's not a double negative this time. And let's finish this problem off here. I need to put it into the same notation we've been putting it in here. Distribute out the 7. Okay. We get that right there. Move over the 9. And we end up with y equal to 7x minus 44. The final answer then would be what? It would be f of x equal to 7x minus 44. Okay, so it's the same idea where you have the slope and you have a point and you go from there, but it's just a matter of figuring out what the final slope is by taking this step here where it says that it's perpendicular to this equation. So when it's perpendicular, you figure out the slope of that equation and then you find out the perpendicular slope, okay, since the real equation is supposed to be perpendicular. Okay, let's go down here to the last two problems. Notice in number 4, it's exactly the same as the problem we just did where it says perpendicular. In fact, they're really nice to you here. This is already in mx plus b form. So the slope of the equation they gave you is 1/3, isn't it? But since it said perpendicular, what do? We have to take the 1/3 and we have to find the negative reciprocal of that to find the final slope for the perpendicular line that we're trying to find. Okay? Because it's supposed to be perpendicular to the 1/3. Parallel is different though. And again, they're nice to you once again here. It's already in the mx plus b form here, y equal to mx plus b. So the original slope they gave you is negative 5. But since it's parallel, that means it stays the same, okay? Perpendicular, you take the negative reciprocal. Parallel, it stays the same. So the final slope on this problem is going to be negative 5. And then you go ahead and use the points that they pass through right here in order to finish off the problem in the same way we did here and then the same way we did a lot of the problems. So please try 3 and 4, okay? And then we'll take a look at the answers as usual right after that. Okay. Number 3, we determine that the slope of this equation is negative 5. Since it says parallel, that means you keep the slope the same. The parallel slope is still going to be the same number, negative 5. And then we plug it into that secondary formula, the point slope formula, like this. Because of the fact that the x is not 0, we have to use that formula. All right. We then do our normal steps to get it into the final form here. Distribute it out. Move over the 7, and we get y equal to negative 5x minus 17. Replace the y with f of x, and then you are at the final answer right here. All right. This one right here, the perpendicular slope is going to be negative 3 over 1 because you flip over the 1/3. That would make it positive 3 over 1, but then you're supposed to change the sign. That's why they call it, a negative reciprocal. So negative 3 over 1 is the perpendicular slope, otherwise known as negative 3. We plug that into the formula, where that's the same formula we used in the last problem. because this is not 0 right here. So you can't say that b is equal to 2 unless this number is 0. So we use this formula instead. Okay, remember it's plus 4 right here because it was minus negative 4. All right, we distribute, move over the 2, and finally what? We finally change y to f of x. Okay, and so that, you guys, is how you figure out the equation of a line based on the information that they give you that describes the line, that describes the graph. Okay, so let me know if you have any questions as usual, but this concludes Chapter 2, all right? And so in the next video, we will start Chapter 3. You have a good day and take care.